A recent Goldman Sachs economic research report estimated that the impact of generative AI on the global economy would be an additional 7 percentage points of GDP. I mean, this is a kind of outrageously large number. I'm not sure they'll be held accountable to it, and it's very hard to make such predictions. But the fundamentals are there, right? I've been working in this field for over 20 years, and every year a problem that we previously couldn't solve and had almost kind of plateaued in terms of our rate of advancement, we have kind of eventually achieved superhuman performance. So I'm talking about individual tasks like recognizing handwriting, understanding the handwriting written on a letter or an envelope or in a document. I'm talking about understanding speech and synthesizing that to text, playing chess, folding proteins. Again and again, these problems fold to AI surpassing human capabilities. And what we've seen in the last 18 months, 24 months, is an almost kind of, the gradient here of progress is just getting steeper and steeper as data becomes more abundant. Moore's law continues to play out, and our ability to leverage these neural network technologies gets stronger and stronger. These almost vertical lines at the rightmost point are all a result of the unlocking of generative AI, right? And our ability to, write code, create images, reason from natural language. So, as we try and think through these problems and come to these kind of estimates of where, what is the impact of this technology going to be? Where is this impact going to play out? I think one of the first kind of papers in this space was, GPTs are GPT. So generative pre-trained transformers is the architecture of these neural networks, which is driving this generative AI revolution. And GPTs is also a kind of term that economists use for general purpose technologies. Things like electricity, things like personal computers, the microprocessor, and now these neural networks. And I think one of the most kind of interesting things is they took these statistics that the U.S. labor force, Department of U.S. labor or whatever puts out, where they publish all of the different kind of roles, the percentages of job roles, the percentages of these roles that they form the economy, and they have all these statistics around the tasks that these people perform. And they looked at these tasks kind of task by task and analyzed what percentage of that task could be done by generative AI. And they found that 20% of workers could have about 50% of their work augmented or improved with this technology. And I think what we're looking at there is we're talking about software engineers writing code maybe a little bit more with fewer bugs, a little bit faster, or copywriters writing an article or some marketing content a bit faster. But the much more interesting thing is that when they took those tasks, but they also thought about how this raw technology could be augmented with additional tools and software around it, this percentage massively increased to 46 and 56% of a kind of all tasks. So really the key to unlocking this value from this generative AI technology is about how we augment it and embed it in our products and services. And that's what I really kind of want to talk about. UiPath is a kind of leading platform in the world of business automation. We help businesses, including large financial services firms or utility firms, every industry vertical, every line of business. We help these organizations be more efficient, more productive by automating the repetitive and mundane work. And I want to kind of think about how generative AI can really kind of be used to provide value in this space. Well, I think there's kind of one thing that we can take for granted. There's so much hype, there's so much fervor around AI. It's often kind of hard to figure out the signal from the noise. And I think it's hard to make a lot of predictions, but some predictions I think are pretty firm. and I basically bet the house on this. Generative AI is going to get much, much better at processing richer modalities of data. So today, we see it performing very well for pure text. It's going to get much, much better at processing sound, audio, images, video, longer sequences, higher fidelity, more consistent, there's less kind of inconsistencies or logical errors in the sequences that it generates. I think these things are kind of guaranteed. But I think we need to take like a kind of step back almost and think, what does it mean to be intelligent, and how is value realized from intelligence, right? And what are the core kind of faculties there? For me, perception is absolutely critical, right? So often we say the most intelligent person, or the most, is just the person with the access to the best information, the most timely information, the most correct information. Access to information is absolutely critical in terms of, your ability to make intelligent decisions. The second, obviously, core capability is the ability to reason with that information, to process it, to synthesize it, to make deductions and judgments. And I think, I always say that I think we all have a friend who's very well read and very good at kind of thinking and reasoning, but doesn't do much, right? So you have to act to actually get value from intelligence. If you don't do anything, you can be very entertaining, but you might not actually yield much results. And so perception, reasoning, action obviously happen in this kind of loop, feedback loop. And then the final missing component to truly unlock value is obviously, to increase the value over time, is to learn from our historic actions in this space, right? We exist in a perception, reasoning, action kind of loop, and then we also have to stop and look back and reflect at what, our history, our pasts, and think through how we could do things slightly differently to improve outcomes. So that kind of ability to learn from experience, I would say, is one of the most kind of important, critical faculties. And so obviously the talk of, the subject of my talk is about how do we do this at work? I mean, in the world of kind of office work, the work that I imagine most of you to be employed. How can we make our businesses truly intelligent systems? So what are the kind of, what are the equivalents of these faculties in the office environment? Well, I think during COVID we all worked from home. What did we need? We needed access to all of our core systems, the user interfaces that we use to do our work. Programmatic interfaces if we are software engineers. We process documents, we read documents, we look at photos, we read messages, we read text. Without those modalities of data and being able to ingest them, we can't provide value. So those are kind of the baselines for the capabilities, the perceptual capabilities we need intelligent systems to have at work. Reasoning can be both kind of logic-based, procedural, but increasingly now, traditional AI supervised or specialized AI models, generative AI, and of course, human reasoning. Right? There are still a whole bunch of reasoning tasks that humans are uniquely qualified to do and are the best at. The third is obviously kind of the ability to act, to take our deductions, our predictions, and put them into action. Again, APIs, user interfaces, and data stores. And then how do we learn from our, what's the experiential data that we can learn from at work? It's the tasks, the processes, and the decisions that our organizations have collectively made. So at UiPath, the platform is really a capability to make all of these capabilities easy to use, democratized, so we can build, automations to remove these kind of mundane, repetitive tasks from our daily workload. But I kind of want to think, very broadly, is that I would say, the last 200 years, I'm not a huge historian of the economy, but 200, 300 years, right, of every kind of value chain, every process, has been a story of humans and machines working together and us dividing kind of tasks and work between what's best for a machine to do and what's best for a human to do. And we're now making a transition in our economy where every process, every task, every value chain will be a combination of humans and machines and AI agents or AI-enabled systems. And this is a huge challenge. We have to effectively re-augment, redesign, re-implement pretty much every process, every product, every team in the economy that matters. And I think a lot of economists have studied previous waves of general purpose technologies and how long it took those technologies to actually realize value in the economy. So, kind of famously, when electricity was kind of first kind of being deployed in the economy, people would just replace the large steam engines in a factory with a very large electric motor. And that didn't yield huge economic advances. It was probably just a bit quieter, a bit less smoky, but it didn't actually yield huge economic advances. The economic advances were realized when we changed the way in which production line work by leveraging the fact that motors could be any size and distributed kind of in a much more ad hoc way through the production line. And then there was a redesigning of how that process work would be done. And so I think in the world of work, in the world of the office, we have an analogous situation. Are we just going to deploy kind of AI in a place that's convenient for us to deploy it today, or are we going to fundamentally change our tasks, the ways of work, and how we distribute them? And so I think it's really kind of interesting one of the biggest kind of questions that I think about is like, what's the limiting factor here? Because, previous waves of technology adoption, if you think about moving from steam to electricity, there's a huge amount of kind of physical work and then infrastructure that had to be done here. Software can, in principle, move much, much faster. Are we going to see similar delays, like from electrification to the GDP, kind of productivity advances from electrification, from steam to electrification in this AI era? And personally, what do I believe is the biggest bottleneck? I believe the biggest bottleneck is our ability to conceive of better ways of working, right? To actually have the imagination of how we can redesign our processes and how we work as teams. And to that end, I think, we need to develop tools and software that can help us do that faster. And it's possible, right? What is the process of innovation? I think often it comes down to firstly kind of observing kind of a systematic opportunity for improvement, and then conceiving of a different way of working. And at UiPath, that's something that we invest very heavily in. We call them our discovery tools. We have communications discovery tools where we mine the historic conversations a business has. Conversations are typically always about kind of problems or opportunities. You don't talk about everything that works. You never talk about stuff that's working. You just talk about stuff that could be better or isn't working. When you listen to those conversations on whole, you'll discover systemic opportunities there. We have task mining tools which will observe the work that people do on their desktop in a data secure and privacy aware way, and find those repetitive opportunities for improvement. And we have process mining tools which take a kind of more systemic look at how work propagates through the different systems of record within an organization to uncover systemic opportunities there. So I think software can be used to make this transition faster, more efficiently, and more impactfully. Thank you.